Alright, so far we've seen some quadratic examples that we were able to solve pretty quickly by just simply factoring them. Right, we set y equal to 0 because we're interested in the solutions of the equation, the x-intercepts, where our y value comes out to be 0. And then we can take a look at this and see if we can just break this into two things that are multiplied together, two factors. And we're able to do this a lot of the time just by kind of thinking through this. I've got to figure out what multiplies to give me the c value and what adds up to give me the b value. So what multiplies to get 6 at the same time gives me 5? Well, 2 times 3 is 6, and 2 plus 3 is 5. So a lot of times we can approach the problem like this, and then we can look at this and say, okay, I got two things multiplied together. Either of them could be 0 since our product is 0. So then we can solve each little chunk to find our roots, our x-intercepts. Okay, so we get -2 and -3. We verified that this is a correct way to do it, right? We can throw this onto the graph, and we can see that we have two roots, -3 and -2, just like the algebra said. So this is what we've seen so far. Unfortunately, this doesn't always work. Not every quadratic is going to be able to be solved with simple factoring. For example, let's look at this example, where if we try to do this, we got to come up with numbers that multiply to give us 4, and then also add to 6. Well, there aren't any numbers that do that, at least not any that we know, right? 4 times 1 and 2 times 2 doesn't work. So we've got to come up with another way to solve these types of problems. So today we're going to talk about a method called completing the square. And I really like this method because it's really clever, and it also always works. There's never a quadratic that is unsolvable by completing the square. It can get pretty messy, but it will always work. So when it comes to quadratics, there's all kinds of different strategies. We'll talk about a couple of them in this class, but there are two that are really, really great because they never fail. The first is the quadratic formula, and you might have seen this before. Quadratic formula looks like this: -b plus or minus the root of b squared minus 4 times ac all over 2a, where a, b, and c are talking about the three parts of our standard form. A is the coefficient of x squared, b is the coefficient of x, and c is our constant. Now, this does always work, so it's a good method to know, and it's really straightforward. So you could easily program a calculator to do this for you because it just takes some numbers and plugs them into the right place. So if you already know this method and you're comfortable with it, I encourage you to do that. But this is not what we're going to talk about today. Instead, we're going to use some algebra tricks to solve this quadratic. So in order for us to understand completing the square, we need to first understand what we mean by a perfect square trinomial. So trinomial just means we have this function with 3 terms. Okay, tri means 3, like a tricycle. So a perfect square trinomial, we've seen these before. This is where we go to factor and we see something kind of cool happens. We get the same factor twice. So 5 times 5 gives me 25, 5 plus 5 gives me 10. So we end up with the same factor doubled. So what's really nice about these types of quadratics is that we can rewrite it as x plus 5 squared. Right? X plus 5 times itself is the same thing as x plus 5 squared. And if we can get our equation to look like this, which is vertex form, then what we can do is solve with really straightforward algebra. Instead of having to use the zero product property or fancy factoring tricks, we can just solve this with straight up inverse operations. I can get rid of the squared by square rooting, and then I can subtract 5 from both sides. So it turns sort of a complex problem into a really straightforward one. So what if we could get all of our quadratics to be perfect square trinomials? Right? Perfect square because their two factors are exactly the same. Well, we can do that. So let's come back to this example that we couldn't factor the way we've learned so far. Okay, so we still want to set this equal to 0 because we're still interested in when is y equal to 0, right? When are we on the x-axis? And we've seen that we can't solve this by factoring. There's no factor of 4 that would add up to 6. So what I'm going to do here is take that 4 and move it to the other side of the equation. I'm just going to get this out of the way for now. And then we're going to really focus on what is the perfect number that I would need to complete the square. That's where we get the name, completing the square. I want to turn this into one of those perfect square trinomials like we had over here. So what number would I need? And it feels like a really tricky problem to figure out, but it's pretty straightforward. If we can picture this as a square, all right, we've got our x and our x squared part here, and then the 6x is going to be split perfectly in half, right? Because we want the sides to be the same. So half of 6 is 3. So we get our 3x's here for a total of 6. And then we'll have 3 times 3, which would give us 9. So the perfect square trinomial we're looking for has a 9 right here in the constant slot. So let's force this to be perfect square. We're going to take this and add a 9. And we're allowed to do that. We can just add a number in as long as we also add it to the other side of the equation. So we can add 9 on the right, but I can also add 9 on the left to keep things equal. And let's see what happens. So now we've got 5 over here, 9 minus 4. And then with this, we're going to be able to factor this. So using the method we already know, we can break this down into x plus 3, x plus 3. X plus 3, x plus 3 is x plus 3 squared. All right? To multiply something times itself is to square it. So now that we've written it like this, we can solve this without having to do zero product property or anything like that. So we take the square root of both sides. We get the square root of 5 is equal to x plus 3. All right, the square and the square root cancel each other out since they're inverse or opposites. Okay, so what's the square root of 5? Now, the first time I do this problem, I'm going to use decimals because they're easy to work with. But the next time we do this, I'm going to stick with the radicals so that we get the most exact answer. But just starting out, radicals are a little uncomfortable to work with, so we can throw into a calculator. Okay, so the square root of 5 is 2.24. Remember though that when you take a square root, there's actually 2 answers. The calculator's only going to tell you one of those, but negative 2.24 works as well. Negative 2.24 times itself would also give you 5. A little bit off because we rounded, but whether it's negative or positive, both of those work. So anytime you take a square root, we have this plus or minus. There's 2 answers, so don't forget that. Okay, so I've got x plus 3 is either 2.24 or negative 2.24. So if we subtract 3 from both sides, we get x is negative 3 plus or minus 2.24. All right, so those are our 2 answers. It doesn't look like 2 answers because we've written it on one line, but this plus or minus symbol is just a way of mathematicians being lazy, so they don't have to write it in 2. So let's figure out what are the actual values for x, because this doesn't feel super useful. So negative 3 plus 2.24 would give me negative 0.76, so that's our first answer. And then negative 3 minus 2.24 gives us our second answer, negative 5.24. Real quick, jump into the graph and check if that makes sense. So here's that equation we just solved, and let's check the roots. Negative 5.24 and negative 0.76. So the same thing we got, but we rounded a little. Cool, so that's the basic process. And I know that was probably really overwhelming if this is the first time you've seen this, but the idea is kind of simple. We take our quadratic and we get our constant out of the way. Just shove it over to the other side. And then we got to figure out what is the perfect number we need to add here to make this break down the way we want it to make it into a perfect square trinomial. And to figure out that number, all we have to do is take the b value, cut it in half to get the 3, and then we square it to get 9. So let's try this again. There's my problem. All right, so we're going to follow the same process and see if we can solve this quadratic. Because again, we can't factor it. There's no factors of 11 that add up to 8. So let's see if we can make this work. First thing we want to do is get that 11 out of the way. So I'm going to subtract 11 from both sides of the equation. Notice I've left a little gap because we're going to add the perfect number that we need to make this a perfect square. All right, pause the video right now and see if you can figure out what number needs to go here. Maybe look back to the previous problem we did and see if you can figure that out. All right, so hopefully you're able to figure out the perfect number we need is 16. So the way I like to do these problems is I go ahead and start doing the problem as I'm thinking about it here. So I know I want to look and I want to get to this form. So I cut 8 in half to get 4, and then I'm going to have to square that 4 to get my constant. So 16 is the perfect number we need, again, because that's half of 8 squared. We can't just go around adding 16 though without also doing it on the other side to keep things equal. 16 and negative 11 make 5. All right, from here we can solve. So we take the square root of both sides. We get x plus 4 equals plus or minus the square root of 5. So then we can subtract 4 from both sides, and we get negative 4 plus or minus the square root of 5. So there's our two answers. And again, we can just leave it like this. This is a perfectly acceptable way to write your answers. Or if we want to be a little more clear, we could write it as two separate answers. So x is this, oof, or x is this. Either way works. All right, and this is the preferred way to answer in math. In math, we like exact, precise answers. So the square root of negative 5 is as exact as we're going to get. If we round it off like we did earlier over here, then our answers are going to be a little bit off always. Okay, so if you're super overwhelmed as it is, go ahead and stop here, and you can go ahead and work through the practice problems I have. But the next thing I'm going to do is look at a more advanced problem. Okay, so here we're going to take a look at what happens if we don't have a 1 in front of x squared, and the numbers get a little uglier. Can completing the square still solve the problem? So let's take a look. So first thing I want to do again is just get this out of the way. That 9 is just causing trouble. So we're going to scoot it to the other side. And now I can't just start adding my constant here because I've got this 4x squared instead of just regular old x squared. So if I were to break this down right now, it wouldn't just be x plus a number, right? It would be, well, 2x plus a number. But in general, what we want to do is factor out our 4. So let's do that first. We've seen this before from last class. I'm going to take a 4 out of the equation here. So we've got x squared now, and then I've taken a 4 out, so now we have 4x. So again, this is just me factoring out, undistributing a 4. If we use our distribution property, we'll see this is the same thing. 4 times x squared, 4 times negative 4x. Okay, so now that I've done that, now I can fill in this blank, and I can put in the perfect constant to make a perfect square trinomial. So what is the perfect number we need? Pause and see if you can figure it out. Let me not do that yet. All right, so we need half of this number squared. So half of negative 4 would be negative 2. Negative 2 squared would be 4. So let me do this in a different color. 4 is that perfect constant we need to add to make this square work. All right, but don't forget, we also have to add whatever we put on the left, also got to put that on the right. This, however, is incorrect. This is bad. We didn't add 4 to the left side of the equation. We added 4 times 4. Okay, so you want to be really careful in this situation. This is where it starts to get a little more complicated. We didn't add 4 to the left side of the equation. We added 16, right? 4 times 4. All right, so that's going to give us 25. And now we can start solving from here. And again, this one's a little bit uglier, but this is actually going to work out pretty nice for us. So first, before I take the square root, I'm going to get this 4 out of the way by dividing. So I got x minus 2 squared equals 25 over 4. Now I can take a square root. Luckily for us, these are both perfect squares, so I get plus or minus 5 over 2. All right, square root of 5, square root of 4. When you take a square root of a fraction, just square root the top and the bottom separately. All right, it's a little ugly. Now we can get x alone by just simply adding 2 to both sides. So x is equal to 5 halves plus 2, or negative 5 halves plus 2. So I'm going to write this out first so I don't confuse myself, and then come up with my 2 answers. All right, so 2 would be 4 halves. Yes, 4 halves. So 4 halves plus 5 halves is 9 halves, right? Or 4 1/2 is a good answer. 4 halves minus 5 halves would be negative 1/2. So those are our 2 answers. Sweet. And we can verify these by throwing them into the calculator, throwing them into Desmos, and letting Desmos graph them out for us. All right, sweet. So I hope this helped you get started. Some of the time, completing a square gets a little ugly. Right? There are times where it's not nice to cut our middle value in half. We can imagine situations where this could get really brutal, right? If I had to cut this in half and complete the square, right, we'd get our 4 out of the way, right, and move that over, but then I'm going to be left with 3 halves squared. So that perfect number I'm going to need to add, sorry, I'm kind of getting off here. The perfect number I'd have to add here would be 9/4 would be the perfect square. So this can get pretty ugly, but we're not going to get that deep into it. The point is that completing the square always works, especially if you're really strong in algebra. If you can follow those simple algebra properties that we've learned, then this is a really, really nice method to have in your tool belt. It never fails, just like the quadratic formula, but doesn't require any memorization, just some technique and logic. Thanks, guys.